class. This is a review for Chapter 7. Chapter 7 is titled Systems of Linear Equations and Inequalities. All right, so equations have equal signs. Inequalities have greater than or less than signs. So what we got here are two kinds of questions. Some with equal signs and some with inequalities. But they're all systems. What's a system, you might be wondering? A system of equations means one question with more than one equation. Two equations working together. The solution is what we have to find. The solution is, for a linear equation, is where the lines intersect. Okay? Or another way to think of it is the solution is the values that make both equations, if you have two, true. Generally, x and y. Okay? So, systems of equations, we have to solve them, find the solution. That's where the lines intersect if we were to graph them. Or the values of x and y that make both equations true. Generally, when we're solving systems of equations, we use either the substitution method or the elimination method. Okay? Inequalities are slightly different. A system of inequalities is solved generally by graphing. The solution is the region that makes both both inequalities true, or the region that's shaded by both, overlapped shading. For example, if this one is shaded up here and this one is shaded down here, the solution to this system is colored green. It's just this. Okay? So here we go. Ready for some examples? Question 1. I think you should. Okay, here's a practice test. Are you ready? Starting now. Practice test, Chapter 7, Systems. Question 1. I'm going to just write it down. I'll give you a chance to do it, then I'll show you if you got it right. Okay? Okay, here we go. Okay, question 1. I'll give you a second to try to do this, unless you want me just to show you right now.
No, we can do it. Don't do that.
Don't do that. Okay, I'm not going to do it, but for those people that may be stuck right now, can anybody tell them, is this a question where you should probably use substitution or elimination? Okay, good. You use substitution generally if you see y by itself or x by itself. Okay? And in this case, I see y by itself. So you're going to substitute 6x minus 11 in this spot here for the y. Okay? And then solve it for x. This is a system of equations. You're going to solve this using the substitution method. Now remember, the solution is not just what x equals. There's x and y. It's what x and y equal that'll make both equations true. So your answer should look like this as an ordered pair, which represents the location that these two lines intersect. Very good. Everybody get a chance?
No.
Yes.
Did you guys enjoy the earthquake drill today?
It's like that was like the most intense.
Did you go under your desks?
No, I didn't.
You're supposed to go under the desk. You go under the desk because I guess during an earthquake stuff falls down. So if you're under the desk,
They protect you.
What am I supposed to do? Like, if I'm gonna fall down, I'm gonna fall through the ceiling. So I'm like, you know what, whatever, I'm gonna be comfortable before.
what if the floor doesn't cave in, the roof does?
And that's why you're under the desk.
That's right. The desk is like your shield.
Where would you go there?
Good idea. Let's all get in there.
Just one person. Two.
That thing locks. I could lock somebody in there. Creepy. All right. You should have written this. Okay?
I was going to ask you.
And then you solve this for x. Distribute. Negative 2x minus 18x plus 33 equals negative 7. Now we're solving this for x. You should probably combine like terms here. We're just trying to get the x by itself here. I'm going to minus this 33. I'm going to have negative 20 times x equals negative 40. And then the last step is to divide by negative 20. X would equal 2, right? That's this number. Now, we have to figure out what y equals when x is 2. So you take the x and you plug it back into either of the two equations. I'll choose the top one. Put a 2 here. Y equals 12 minus 11, right? Which is 1. You don't have to graph it. Solution is 2, comma 1. Any questions? Now, I'm not sure yet. Now, what you should do on the test is check to see if this is right. And the way you do that is you plug in 2 and 1 into both equations. Okay, so the x's are 2s. So you take out these x's and you imagine they're 2s. And you take out these y's and you imagine they're 1s. And if both of these are true, then you know you got it. Okay? So let's check the top one. Does 1 equal 12 minus 11?
Yes.
It sure does! Woo! Okay, negative 4 minus 3 equals negative 7. Is that true?
Yes.
Yes, it is. This must be right. If you do that, then you should get 100% on this test, because if you plug it back in and it's wrong, then you don't turn the test in, you just try to do it again. Right? Okay. Any questions about number 1? You sure? Okay. Here we go. Number 2. 6x plus 6y equals negative 6. 5x plus y equals negative 13. Natalie, is that a system?
Yeah.
Correct. Tiny, why is that a system?
Does it have 2x and 2y?
Okay, two equations.
Yeah.
Are they even equations? Are they inequalities?
Very equation.
They're equations because...
They have equal signs.
All right.
Have the-
Okay, so we have a system of equations. Substitution or elimination.
That's elimination.
Okay. You actually could use either on this. If you wanted to, I think I would probably do elimination, but if you wanted to, watch this.
How can you
This bottom equation if I subtracted 5x from both sides, it would look like this. Right? Now the y is by itself. Now I could use substitution. See, now I have the two equations I'm dealing with are this one and this one. The bottom black one is now that new red one.
Well, I would prefer that one.
So if you want to, you could do that and then substitute this in for y right there and solve it just like we did the last question. Okay? That's one option though. If you want to do substitution, you can. You just have to put one of the equations in y form or x form. Okay? Now, if you don't want to do this, your other option is the elimination method. Right? The elimination method would work like this. You'd multiply the bottom equation by negative 6. Because what that'll give you is negative 30x minus 6y equals negative 6 times negative 13 is 78. And if I leave the top one alone, I'll have created this situation where I can add these two together and it'll make 0y. The y's will be eliminated. So add 6 minus 30, 6 minus 6, negative 6 plus 78. Right? And you have a real simple equation here. You just do some dividing on both sides. X equals negative what? 3. Now again, that's only part of the answer. So far the answer is negative 3 comma something. So the question is, what is y when x is negative 3?
When we plug it in to the other one, how do we know which one to plug it in?
You plug it into either one.
Oh, okay.
And if negative 3 is correct, you'll get the same answer no matter which equation you plug it into. That's kind of the point, is that they both work. Alright, so 5 times negative 3 plus y equals negative 13. This is negative 15 plus y equals negative 13. I'm going to add a 15. And I have y equals 2. So, Anthony T., where does this line intersect this line? Where do those lines intersect? If I were to graph them, where would they cross each other? Give you a hint. Good. Good job. The solution is where the lines cross. Any questions? So on the test, you have to do this solving systems of equations. You can use substitution method, or you can use elimination method. Okay? Okay, let me find some more here. My list of questions. All right, you ready? Number 3? Here we go. Practice test, question number 3. Solve. Raise your hand if you're doing the substitution method. Reggie, you're doing substitution? That's fine. You could do substitution. There's just one step you have to do first before you do substitution. What would that be?
Add 3y.
Yeah, if you did this, right, to the bottom equation, it would look like this. Right? x equals 3y minus 6, then you could substitute this here. That's one option. You don't have to do that. You could do substitution. It's like two tools. You could use the hammer or you could use the screwdriver. On this question, both of them work about the same. So it's like you have a nail to nail in. You could either use the hammer to nail it in, or you could use a screwdriver to nail it in. Has anybody ever done that? Nailed something in with a screwdriver?
You said that last week.
Oh, excuse me. It works, doesn't it? Sometimes. I don't know if I would use substitution though. Now, when you do elimination, you have some options here too. There's more than one right way to do this. Who multiplied the bottom equation by 4?
I'm not surprised.
Shh. Jennifer multiplied it by 4.
Mr. Kong,
Shamel, what?
when you're using elimination, does it matter? Does the numbers have to be the same, like negative 4x? Does it have to be positive 4x? Or
Yeah, so that when you add them, they make 0.
Oh,
Because if they're both the same, it's like positive 4 and positive 4. If you add those, that makes 8.
right.
Or negative 4, add those, that makes negative 8. Technically, you could make them the same. You would subtract them to make 0, but you're going to run into problems usually if you do that. So if you just try to make them the opposites and add them, it's usually the simplest way. All right, so one option again is multiply the bottom by 4, so you have negative 4 and positive 4 here, right? Another option is multiply the bottom one by 3, because then this will be 9 and negative 9. Okay? Either one is good. So who multiplied by 4? Who multiplied by 3?
4 people.
Okay. I'm going to do 3 then, I guess. But if you multiplied by 4, don't freak out. We're all going to get the same answer in the end. Okay? Add. Negative 4 plus 3 is negative 1x. Good. Cynthia, what's 9 plus negative 9?
0.
Good. 9 plus negative 18? Good job. X is 9, right? Plug her back in. 9 minus 3y equals negative 6 minus 9. Negative 3y equals negative 15. Divide by negative 3. Y is 5. Okay? Any questions? This is a solving system of equations here. Okay. Now again, on the test, what you do is you take the 9, which is x, and you put it here and here, and you take the 5, which is y, and you put it here and here, and you check to see if those are both true. Sometimes you could do that in your head. Okay? So, if this is 9, and this is 5, this would be negative 36 plus 45. Does that make 9? Yes. If this is 9, there would be 9 minus 15 equals negative 6. Is that right? Sure is. Okay? So, where do these lines cross each other?
Right there.
9 and 5. Okay? Any questions yet? No? Okay, number 4. Ready?
Yeah.
This one looks like the other ones, but it has a trick built into it.
You could.
Who wants to use the substitution method? Nobody good. Me neither. You want to use elimination? Okay, so what are we going to multiply by?
-2.
-2 on the top?
Yeah.
Okay. Now let me just ask you something. Are you multiplying by -2 so that this becomes -6?
Yeah.
Okay. And I'm going to multiply the bottom by nothing, right? Good. Okay, so now,
Oh, it's 2?
yeah, now watch what happens. This is a weird thing about this question. Look, I asked Shamel, why you want to multiply by -2, and she said, so this would become -6, so this would happen, right? Like we did this part on purpose, right? But look, this makes 0, 2. That sort of just happened by accident, right? So 0x, 0y, there's 0. There's nothing over here. 0 equals -22 plus 2 is -20. Now, if this happens where both variables cancel out, right? The answer is either there's two choices. The answer is either no solution, or the answer is infinite solutions. Okay? Now, you have to decide when this happens, which one is it? Is it no solution or infinite solutions?
No solution.
If the way you know is if after it cancels out and you have like just a number on the left and a number on the right, okay? If this is false, no solution. For example, does 0 equal -20? No, that's not true. So the answer is no solution. If this is true, then the answer is infinite solutions. Like, for example, let's just imagine some situation where this said negative or 0 equaled, and this turned out to be like let's change this. This is a 22, so this is now 22, right? -22 plus 22 is 0. 0 equals 0. Is that true? Yeah. Both x and y still canceled out, and when that happens, your choice is either this or this. If it's true, 0 does equal 0, then that would be infinite solutions, right? Back to our question, though. This was false, so no solution. Now, one last thing. Again, the solution is where the lines cross each other, right? So if there's no solution, that means the lines don't cross each other, right? No solution means the lines don't intersect, which must mean the lines are good, parallel. Parallel lines will never intersect. Now, no solution means they don't intersect, they're parallel. What about infinite solutions? That means basically they intersect everywhere, not everywhere, but at an infinite number of points. How could that be possible? How could two lines cross each other more than once?
If they're curved.
Like that?
Linear?
Well, I'm talking about two straight lines, two linear. Like you have to make the line with a ruler.
Straight up.
How could two lines cross each other more than once?
Being the same point.
Straight.
They can't cross that.
Are you saying like
They have
this?
the same slope. If they have the
Same
same
slope as this. They'll never.
They might intersect.
They'll only cross once.
Yeah. Don't they keep crossing?
They cross more than once,
Oh.
and they're straight lines.
What if it just stay straight at the same point?
It's the same line on top of it. It's a line on top of a line.
That's what I said.
Infinite solution means
Straight up straight.
same line twice. So basically like this. Line 1 looks like that. Line 2 looks like that. See, they're touching each other everywhere that they possibly could touch each other. Okay? All right, any questions? Systems of equations? No? Okay, number 5. Yes. Yeah. Okay, Okay, so hopefully you realize now we've sort of moved into a new area of chapter 7. We're no longer in the equation world. This is inequality. Okay? I would recommend graphing these lines. And the solution is where the shading overlaps. Do this one with red and this one with blue. So those are both in mx plus b form, right?
Yes.
The red one, the slope and the y-intercept. This is -5. This is 2 over 1. This number is the m. This is the b. The blue one, the y-intercept is 1. The slope is -3 over 4, which is like -3 over +4. Any questions? -5 is the y-intercept of the red. Go up 2, +2, +1, go right 1. 1, 2, 1. 2 about there. Now we have 2 points. We're ready to draw the line. But because we have an inequality, we have to ask, dotted or not dotted?
Dash.
Dashed?
Yeah,
Yes.
it's not equal to.
Okay?
Can I get some water?
Yeah. If you haven't been catching on to this, the rule is if it's not equal to, if you have either of these, you draw a dashed line. If you have either of these, you draw a solid line. Okay? Dashed line means it's not part of the solution. It's just a barrier. All right, the blue one. Intercept is 1.
Down.
-3, down 3, +4, right 4. 1, 2, 3. Or whatever that would be. 1, 2, 3. Over 1, 2, 3, 4. In here somewhere.
That's 6.
Okay. Is
It's a solid line.
a solid line. Okay. Now we got to figure out where to shade. The red one, it says y is less. Y is less on these we shade
To the left.
below. Y is greater, we shade above. So we got to go below the red, above the blue. Below the red, above the blue. That's the solution. Any point in here is a solution to this system. Any point outside of there is not a solution to the system. A point on this dotted line is not a solution. A point on the solid line is a solution. Okay? Any questions about 5? We're almost done.
No.
Sure? Okie dokie. Can I clear this off here? Everybody got this down? So tonight when you practice for the test, you should just try to do this question again, try to do it, and look at mine and see if it's the same. If it's not, watch this video. Okay?
Oh, you're making a video?
It's recorded right now.
Number 6.
Is that
For
before?
a second, I thought that said yes.
You know that said yes?
Yeah. Why actually?
Oh, this looks like a E?
No, like I just glanced at it. I thought it said yes.
No, look here.
I'm a hurricane.
Like, you know when you're going really quick and you write,
Like that?
it just looks like, yeah.
It both says Y.
Okay, it doesn't say yes. It says y is less than 5. Okay.
Okay.
Okay. Whoosh. Okay, blue one.
Okay.
M and B. Oh, there's no x in this one. This you could think of this as y is less than 0x plus 5. The b is 5, the slope is 0. Slope is how steep the line is. So if the slope is 0, the line is flat.
Yes.
1, 2, 3, 4, 5. Okay, Lynn. Dotted or solid line? Good. Okay. That line should be perfectly flat. My drawing's weird, but just imagine that it's flat. Okay. The red one, 2 is the slope here. It's the coefficient of x. But what's the b? What's the y-intercept on the blue? Oh, the red. Yeah, 0. This is like plus 0. Okay. So the y-intercept is 0. Then we're going to go up 2 and to the right 1. There's my 2 points. Okay, dashed or solid?
Solid.
Whew. Guys are some eager algebra students. Okay, now we got to shade it. This would be y is less, that's below. Y is greater, that's
Wait, Mr.
above.
I'm so confused. Look, the 2, where'd you get the other point from? Up 1 over 1?
You mean this point here?
Yeah, where'd you get that?
That's the y-intercept, it's 0. Good. That's a good question. Because see, look, it started out as y is greater than or equal to 2x.
Right.
That's the same as 2x plus, there's nothing here, right? 0?
There's no slope.
I don't know.
No, the y, it's not that there's no slope, that's the b, the y-intercept. And it's not that there is no y-intercept, it's that the y-intercept is at 0. Okay? Okay, so we got to shade below the blue, above the red.
To the left.
Good. This is below the blue and above the red. Anything in here is a good, Juan Carlos, a solution. Okay? Is that a solution right there? Yes. Is that a solution right there? No. Is that a solution right there? Yes. Is that a solution right there? No. The reason why it's dotted is because a point on the line is not a solution. Solid means it's part of the shading area. Okay? So drawing a solid line is like another way of shading the line. Okay? And dotted is like you don't shade the line, it just like tells you where the barrier is. Okay, number 7, you ready? So these both are missing a y, just x. X is greater than 1. What you do is you go to 1 on the x-axis and you draw a vertical line. Right? Solid?
Yeah.
Yeah, that's at 1. X is less than negative 3. That's a vertical line at negative 1, 2, 3. Now we have to figure out where to shade. The blue one says x is greater than 1. So if you look at the blue line's at 1. So you want to shade, you'd be shading the numbers greater than 1. That would be to the right, right? Greater numbers go to the right. So this one's to the right. This one here says x is less than negative 3. That's the red one. Less than negative 3 would be over in this direction.
Wait, it's
There's
dotted.
no solution, right?
It's not solid, it's dotted.
Oh, the red one's dotted. Good. Okay. So somehow we got to shade over here and over here at the same time.
There's no solution.
You can't do that, right? There's no overlapping. It'd be like, this is yellow, this is blue, where's the green? There isn't one. So there's no overlapping, so if this happens, no solution. Basically what it's saying is, when is a number bigger than 1 and less than negative 3 at the same time? What number is bigger than 1 and less than negative 3?
Yeah, that's kind of like those questions.
Nothing, right? Bigger than 1, less than negative 3. Give me one, Tiny. Give me something. Nothing? Bigger than 1, less than negative 3.
Nothing.
Yeah, there's no, what? What number would that be?
Nothing.
Okay, any questions yet? All right, here's
I
the,
didn't say that.
here we go. It's the last one. Ready?
Is it really the
Oh wait, that's not, wait, I messed this up. It's not equals. It's greater or equal. Okay, so what's up with the blue one? How is this blue one different than all the other inequalities we've done so far?
Fraction.
The blue one's a fraction? We've had fractions.
Oh. Because the other one's not put in Y form.
It's not in Y form. So if you're gonna graph the blue one, I would recommend you put it in mx plus b form. So put it in Y form. Solve the blue one for Y. So let me just do this little magic trick.
And then you switch the sign.
So I got to get this somehow so the y is by itself, right? Minus 2x right? And then divide by negative 3 on all the terms, right? Now, I did this one like this on purpose. Whenever you divide by a negative on both sides, you got to flip the inequality. Good. So y now is less than positive 2/3 x minus 4. So this is the blue equation now, and this red one's still the red one. I graph these. Okay, the blue one, the negative 4 is the intercept. 1, 2, 3, 4. And the slope is positive 2, positive 3. So I'm going to, from the negative 4, rise up 2 and to the right 3. Put a point right there. Okay? Solid or dotted?
Dotted. Dotted.
Solid.
It has the equal to sign.
Good. The blue one still. It's equal. Okay, now the red one. The red one, is the red one in mx plus b? Is it in y form? Is the y by itself? On the red? Yes. It's 1/2 x. Where's the b? It doesn't have a b, so the b is 0, plus nothing. Right? There's nothing there. So plus 0. Good. So the m is 1/2. The b is 0. So that means the y-intercept is 0 right here. That's the first point. And we're going to rise up 1 and run over 2. Right? These lines look like they could almost be parallel, don't they? If they were parallel, they would never cross and there would be no solution. However, are these lines truly parallel?
No.
How do you know for sure they're not parallel?
Because the other one's one.
Why? Oh, yeah, they're going to end up
Two.
The way you know is, look, parallel lines have the same slope. If these two lines have the same slope, then they are parallel. Do they have the same slope?
The one, the 0 one
No.
is
2/3 and 1/2, not the same slope.
dashed.
Oh, the red one's dashed. Good.
I did it the other way. I
It's going to look like this. You just have to draw the line out further. But they will eventually cross, so you should know that. They're not parallel because they have different slopes. Eventually they'll look like that. I mean, that's a terrible drawing. But it'll work for these purposes. The blue is less than, so below the blue. The y is greater than, so above the red. Above the red, below the blue. Okay? This shouldn't like bend right here. This should be straight. Just a bad person drawing this. Which isn't me, by the way. It's my partner here that does all the drawing, and I just do the talking. Okay, that's it. That's what I'm going to test you guys on. Tomorrow, Chapter 7. Any questions? No? Okay.